Let's look at cost functions next. In particular, I want to look at how to derive cost functions from given production functions. Right. So the fundamental question we're dealing with is given first production function, either a one variable input production function or a two variable input production function, and unit costs of unit costs of labor and capital inputs respectively. What is the cost of producing Q units output? So let's look at this separately for the case where we have one variable input production function and two variable input production function. First, deriving cost functions from production function with one variable input. Okay, with one variable input, as we have described, we have a one type of variable input, which is the labor input, and we have a output, and the output will depend on this production function, this one variable input production function. So the total cost of producing Q units will be, first of all, we still have a fixed cost that we have to deal with. This is a cost that's independent of the number of units of output that's going to be produced. This is the cost that's paid to get a certain unit of capital input. And in addition to that, we have a cost associated with labor. And for different units of output that's needed, we need different units of labor. Okay, so if we need, for example, this much, output, using the production function, we see that we need, in order to produce Q units of output, we need L units of labor input. Okay, so we can find L by setting Q equals to F of L. Okay, and then we back out, for example, if FL is square root of L, then the number of units that's needed is going to be Q squared. Right? If Q is L squared. The number of units of labor input that's needed is going to be square root of Q. Okay, so this is how to find the total cost of producing Q units when we have just one type of variable inputs. Now, if both types of inputs are variable, how do we find the total cost of producing Q units of output? Let's take a look at that next. Okay, so let's look at deriving cost function from a production function with two variable inputs. Total cost of producing Q units then will be W times L, but now this L depends on Q, plus R times K, where K also depends on Q. And this L star of Q, K star of Q will be the least costly input combination to produce Q units of output. So this statement where L star of Q and K star of Q is the least costly input combination to produce a given Q units of output. This is a general true statement. General statement. It must be true. So think about what's the least, for a firm to think about what's the least money I need to pay to produce Q units, they have to find how to efficiently and costlessly using their input resources. Okay. Now we'll look at different cases where how this is solved. But in general, this L star and K star have to be the least costly input combination. The first case we'll look at is if the production function is a Cobb-Douglas production function. And we have worked through many cases of this in class and also in your homework. Okay. Let me just describe to you the general recipe you have for solving for the least costly input combination with a Cobb-Douglas utility function, production function. Okay, so the least costly input combination must satisfy two conditions. Okay, of course, again, the emphasis is on Cobb-Douglas production function. Okay. Two conditions are, first, f of L star K star equals Q. Okay. Economically, this means when used efficiently, L star and K star together produce Q units of output. Okay. So if you want to find the least costly input combination L star K star that produces K units, we better find an input combination that actually produces Q units, rather than not it's least costly or not. But then the second condition, tangency condition, guarantees us that this L star and K star combination will be the least costly input combination. Okay? We can guarantee that when the marginal product of labor per dollar at this costly input combination equals the marginal product of capital per dollar. This economically, this means the marginal product per dollar is the same for labor input L and capital input K. And of course, if you read the book, they have an equivalent condition here, but the way they describe this is by introducing an additional concept. I try to eliminate that concept so we don't get more complicated, but in the book, they describe it as follows. They have marginal product of labor over marginal product of capital will equal to W over R. And they call this the marginal rate of technical substitution. But these two are equivalent. Okay? I just want to point that out. Okay? The reasoning is the same as in the utility maximization problem, right? When you spend $1, you always think about how much more utility can that dollar generate. Okay? So if you spend $1, an additional dollar on labor, what can you get in terms of the total output? In terms of the total output, because per unit wise, per unit of labor input, the cost is W. So using $1, 1 over W units of labor inputs are the additional inputs you can get. And per unit wise, okay, let me actually write this down. Okay, so 1 over W times MPL. This is the additional labor input from $1. This is the additional labor input one can get from $1. And the marginal product of labor is the additional output that can be generated per unit of labor. Right? So overall, this is the additional output from spending $1 on labor. Now, on the other hand, 1 over R is the additional capital input from $1. And using that capital input, we can generate additional input, additional output per unit of capital input. So this is the additional output from spending $1 on capital. Since in fact all your money will be spent, on purchasing labor and capital. So it must be the case. So think about a dollar. If you spend that dollar on labor, then this is the marginal benefit of that dollar. On the other hand, because you're not spending that dollar on capital, that's your marginal cost of the dollar. So when you're choosing your money optimally by minimizing the cost, it must be the case marginal benefit equals to the marginal cost. And that's the explanation for our equation here. Okay. Okay, so by having those two conditions, we have two unknowns, L star and K star. So from those two equations, we can find the actual least costly input combination to produce. Okay, so that's the case. I emphasize again, this is the case with a Cobb-Douglas production function. Okay. But if you have a production function that's not Cobb-Douglas, this is not the way to go. Right? Let's talk about the other two special cases. We may have a perfect substitutes production function. Right? Two goods are actually substitutable from each other to produce an output. Okay. Actually, I can tell you here, even though we didn't go through example, this one will be tested on the exam. Okay. And the hint I can give you is that even though we didn't go through this, think economically about this. Don't try to rush yourself and set up some equations. Just think economically about if you want to produce an output and you have two goods that are actually substitutable for each other, what should be the least costly way for you to produce an output? Okay. Let me draw a graph and show you how to solve for this question. Okay. As we have gone through in the homework, you drew a graph of the okay. You drew a graph of the isoquant for perfect substitutes. And it's going to be some straight line like this. This is your isoquant. And you will have isocost curves. That are also straight lines, and they do not necessarily have the same slope. Right? And your least costly input combination will be a corner solution. Remember what a corner solution means? A corner solution means you're only getting one type. You're only going to basically use one type of input. Okay, so think about this. You're going to compare marginal product of labor over W and marginal product of capital over R. Okay. Instead of having an interior solution where you can equate marginal product of labor over W and marginal product of capital over R, you're not going to have some L star and K star that actually gives you equal number for this. Okay, so how do you make the decision whether to purchase everything using labor inputs, produce everything using labor inputs, or producing everything using capital inputs? Okay, so think about this. This is a challenging problem because I didn't go through exactly what should be done, but I believe you guys can figure this out. Okay, so think about this economically, and if you have time, you can also cook up your own example and think about how to proceed here. So this is the first special case. We also have a special case where we could have a perfect complement production function. This, again, will be tested. Okay, so perfect complement production function is telling us that in order to produce an output, we need both types of inputs in pairs. Okay, in some fixed proportions, not necessarily 1-to-1 pairs, but it has to come in some package like 1-to-6 or 1-to-5. Okay. So given that production function, in order to produce 1 unit of output, we need both labor and capital inputs in pair. Remember the example we went through in class? The example we gave in class was in order to produce a document, we need both a typist, a labor input, and a computer, a capital input. And so we need a combination of labor and capital input in this example. So here, if you look at, again, the isoquants, in order to produce Q units of an output, we need, the production function is given as minimum of A times L, B times K. So here, the unit of labor we need to produce Q will be Q divided by A. And the unit of capital we need is going to be Q divided by B. To produce Q units, the least costly way to do so is to use just enough both types of inputs to produce an output. Okay, star equals Q divided by B. Okay. So again, think economically what this means, and how do you come up with the least costly way to produce a certain given level of output when we have a perfect complement production function. We will have a question on this on the exam. It's, again, I'm not telling you the exact way to do this because I want to challenge you, and you can think about economically what should be the correct way of doing this. Let me stop here. This is the end of lecture 18 review.